For this station, we're going to talk about inscribed angles and circles and figure out how to find what an inscribed angle is and what the intersecting arc of that angle is. So to start with, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. The arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intersected arc of the angle. Now our first theorem is going to state that if an angle is inscribed in a circle, then its measure is half the measure of the intersected arc. So for example, the arc from the angle D is half of the arc AB. Now our first example shows that we need to find angle M, and we know it's going to be 1/2 of the arc, which is 100 degrees. So angle M will equal 50 degrees. Our next example already gives us what the degrees is, which is 105. But we need to figure out what the arc from ZWX is equal to. Now, to get rid of fractions, we always multiply by the denominator. And what you do to the one side, you do to the other. So 105 multiplied by 2 is 210 degrees. And that's going to equal our arc from ZWX. Now the next theorem that we're going to look at says that if a triangle inscribed in a circle is a right triangle, then the hypotenuse is the diameter of the circle. In other words, if a side of the triangle inscribed in a circle is the diameter of the circle, then the triangle is a right triangle. So let's look at this example. Well, we know that we have a diameter that goes through the center C. So based off the theorem we were just told, we know x will equal 90 degrees because x is a right angle. Now to find y, there are two different things you can do. Since we're dealing with circles, we know that circles have 360 degrees, and since we have a diameter, it cuts the circle in half. So that leaves us with 180 degrees. Now, we're already given one angle is 35 degrees. So we can find that that arc, or the intersected arc that goes with it, would equal 70 degrees. So if you take what we already know about the diameter and take the arc that we just found and subtract the two, you're left with 110 degrees. So the other arc is going to be 110 degrees. And then based off the theorem, our first theorem, we're going to find that y is equal to 1/2 of 110. So y equals 55 degrees. Now, another thing you could do is that we know that a triangle also has 180 degrees. And we were given, or we know that based off our last theorem, that the diameter is, the intersecting angle is 90 degrees. And we were also given the other angle of 35 degrees. So if you subtract all those together, we can find that angle Y is also 55 degrees based off using what we know from triangles. Now this example, you can look to find what Y and Z will equal to. So first, to find Y, figure out where our endpoints of our arc is going to be. So we know we need to find this red arc right here. So since we're given 75 degrees as the inscribed angle, use the theorem and solve for Y by again multiplying by our denominator, which 75 times 2 is going to be 150. So Y will equal 150. Now to find Z, do the same thing. Find the endpoints. And it just so happened that these endpoints are the exact same from our other arc, or from our other angle. So we can determine that Z is also 75 degrees. Next, we can find, or we need to find the angle JIK. So first, use what we are given. So based off central angles, we can find that arc JI is 83 degrees and arc IK is 143 degrees. So to find what's left, we're going to take 360, subtract it by 143, and 83. And this is going to equal 134 degrees. So the arc from KJ is 134, which means that that central angle is also 134. Now to find the inscribed angle I, we again use our theorem. And take half of our arc, which in this case, we can find that angle I is equal to 67 degrees. Now, if you look at this example, we know that from T to V is the diameter. So right there, our circle is cut in half, which means instead of 360 degrees, we only need to work with 180. So to find angle USV, first we need to find what the arc from U to T is. Since we're given that that inscribed angle is 32 degrees, if we multiply it by 2, then we can figure out what the arc is. So the arc UT is going to be 64 degrees. So now, let me get rid of this. So take 180, subtract it from 64, and we will get 116 degrees for our arc from U to V. Now, that means our inscribed angle, or our central angle, is also going to be 116 degrees. So, angle USV equals 116 degrees. Now, our last example, we need to find angle RST, and we are given that a central angle is 114 degrees. So the arc RT is also 114 degrees. So with that, we use our first theorem to find that angle RST is going to equal 1/2 of our arc. So angle RST equals 57 degrees.